Hey guys, welcome to Lesson 7, Associated Ratios and the Value of a Ratio. So let's start with this classwork problem here. Which of the following correctly models the number of red gumballs is 5/3 the number of white gumballs? So what we're trying to show is that the red gumballs are 5/3 the size of the white gumballs. So basically what we're looking for is a number that's 5 to 3, right? So this here is going to show that the red is 3, and then there's 1, 2, 3, 4, 5 here. Here, the red is 3/5 the white. Well, that's not right. For C, the red is 3/2. That's also not right. All right, so we can see that it's 3/2 because there's 3 red ones here, and we're looking for 5/3. So there's 2 white ones. So basically, whatever number we're talking about first goes in our numerator, and the number we're talking about second goes in our denominator. So here for B, we have 1, 2, 3, 4, 5, and 3, right? So the red gumballs here are 5/3 of the white gumball. So B is our answer. All right, let's go down to example number 2. Example number 2 says the duration of 2 films are modeled below. So film A is 1, 2, 3, 4, 5 long, and film B is 1, 2, 3, 4, 5, 6, 7 long. The ratio of the length of film A to the length of film B is 5 to 7. The length of film A is something of the length of film B. So we're talking about film A first, so that's going to go in our numerator, 5, and our denominator is going to be 7. The length of film A is 5/7 of the length of film B. So if we took film B and broke it into 7 pieces, like we did here, how long is film A in comparison to that? It's 5 long, right? So we're comparing it. Here's 5. Okay, let's talk about C. The length of film B is something of the length of film A. Well, we're going to start with film B. Film B goes here. 7, and the length is 7/5. So if we look at film B, it's 7 long. Film A is 5 long. These boxes are all the same size. We need 7 of these boxes for film B. So film B is going to be 7/5 the length of film A, right? So let's talk about fractions for a second. So 5/5 is going to equal 1. Film A is 5 boxes long. So film A, right, if I had 5/5, that's going to equal 1. But film B is longer than film A, so we need 2 more boxes. That's why we have 7/5. So 5/5 is how long film A is, and 7/5 is how long film B is in terms of film A. Okay, let's move on to our next example. I guess our next exercise. Okay, so exercise 1. Sammy and Caden went fishing using live shrimp as bait. Sammy bought 8 more shrimp than Caden bought. When they combined their shrimp, they had 32 together. So I'm going to say S equals, not hashtag, the number that, not Caden, sorry. Okay, so S equals the number Sammy bought. And K equals the number Caden bought. Okay, so we know, so remember, S is the number that Sammy bought, so this is how many shrimp Sammy has, and K is how many shrimp Caden has. So Sammy bought 8 more shrimp than Caden. So the amount Sammy has is going to be 8 more than Caden. Okay, and we know that however many Caden bought is equal to however many Caden bought, right? Duh, that's obvious. But we know that together, so if we add these together, Sammy's plus Caden, we're going to have 32. Now we need to figure out, so we're going to do a little algebra here. We have 8 plus K plus K. And why am I doing that? Because here, this 8 plus K, right? Remember, Sammy bought 8 more than Caden, so 8 plus K is the same thing as however many Sammy bought. And K is equal to how many Caden bought. So how many Caden bought plus how many Caden bought here plus 8, This is equal to S, right? This is the same amount as S. This equals 32. So this might be new to some of you because you haven't quite done algebra yet. So don't stress about this, but we're gonna do this together. So we have two K's here. So because we have two K's, we're gonna write it like this: 2K. K plus K is 2K. K plus K is the same thing as 2 times K. So for example, let's say I had 4 plus 4, right? If I had 4 plus 4, this is equal to the same thing as 2 times 4. Remember, now we use this dot to mean multiplication, okay? So I'll do that dot here. 2 times K. 4 plus 4 is equal to 2K, so K plus K is the same thing as 2K. 2K plus 8 equals 32. Okay, so we need to get this K by itself so we can figure out how much it is equal to. We're going to subtract 8 from this side, subtract 8 from this side. 32 minus 8. All right, let's do a regular math there. 2, 8, 4, 24. Okay, so now we have 2K equals 24. We need to divide both sides by 2 to get K by itself. Divide both sides by 2. 2 divided by 2 is 1. 24 divided by 2 is 12. So K equals 12. Okay, so K equals 12. And if we know K equals 12, and we can go back to this equation over here, the amount Sammy bought is 12 more than Caden. 12 plus 2 is, 12 plus 8 is 20. Right, this is the same thing as 8 plus 12 equals 20. Okay, so Sammy bought 20 shrimp and Caden bought 12. Let's move to problem B. B says, what is the ratio of the number of shrimp Sammy bought to the number of shrimp Caden bought? Well, Sammy bought 20 and Caden bought 12. So 20 to 12, or we can write it as a fraction, 20 to 12. C, express the number of shrimp Sammy brought, as a fraction of the number of shrimp Caden brought. Well, we know Sammy brought how many? Sammy brought 20. So we're going to write that first, 20. And how many did Caden bring? He brought 12. So it's the same thing as this fraction here, right? The number that we're talking about first goes in the numerator. That's the amount Sammy brought. And the number we're talking about second goes in the denominator. That's the number Caden bought. Just in case you forgot, the denominator is the top of a fraction and the numerator is the bottom. Those might be two good words to add to the vocabulary wall if you forgot. D, what is the ratio of the number of shrimp Sammy brought to the total number of shrimp? Well, Sammy brought 20 shrimp. And how many total shrimp are there? 32. It said that in the original problem. So 20 to 32 is the ratio of the number of shrimp Sammy brought to the total number of shrimp. But we can reduce this ratio, right? We can reduce this fraction. So both of these numbers have at least a 2 in them. So we can divide both numbers by 2 and we get 10 and 16. But look, there's another 2 in here, so we can do this again. So this would be 5, right? Divide by 2 again, divide by 2 again, and 8. So 5/8 is our reduced or equivalent ratio or fraction there. What is the fraction of the total what fraction of the total shrimp did Sammy bring? Sammy brought 5/8 of the total shrimp, or 20/32 of the total shrimp. All right, let's try exercise 2. A food company that produces peanut butter decides to try out a new version of its peanut butter that is extra crunchy. Using twice the number of peanut chunks as normal, the company hosts a sampling of its new product at grocery stores and finds that 5 out of every 9 customers prefers the new extra crunchy peanut butter. So that means that 5 like it, and 9 tried it. Okay, that means that 4 don't like it. For don't like. Okay, 4 don't like it. So the ratio of number preferring new extra country to the total number surveyed is, well, 5 like it, or 5 prefer it, out of 9. The ratio of number preferring regular crunchy to the total number surveyed. So if they don't like this extra crunchy, right, that's what they're trying, this new extra crunchy peanut butter, that means that 4 people don't like it. 4 people like the regular. Okay. The ratio of number preferring regular crunchy to the number preferring new extra crunchy is, so we have to look here. 4 people prefer the regular crunchy. That's this number here. And 5 people prefer the new extra crunchy, right? So here we have this is a part to whole ratio. This is also a part to whole ratio. And this is a part to part. Part to part. The ratio of number preferring new extra crunchy to the number preferring regular the ratio of number preferring new extra crunchy to the number preferring regular crunchy. So we know if the people prefer the new extra crunchy, that's my number over here, they like it, they like that crunchy. So this one's going to be 5 to 4. And this one is also a part to part ratio. Let's use the value of each ratio to make multiplicative comparisons for each of the ratios we described here. The number preferring new extra crunchy, is 5/9 of the total number surveyed. Right? So remember, this says tried. So the people who surveyed it are the people who tried the new peanut butter. So 5/9 of the total people liked the new peanut butter. Really what we're doing is we're taking what we already know about ratios and we're just kind of using fractions to describe that ratio. So let's try this next one. The number preferring regular crunchy is something of the total number surveyed, right? So that is going to be this ratio here. 4/9 of the total people surveyed preferred the regular crunchy. The number preferring regular crunchy is 4/5 of those preferring new extra crunchy. The number preferring new extra crunchy is 5/4 of those preferring regular crunchy. We're taking the exact same ratios that we did in part A, and we're just labeling them down here in part B. We're using the same exact number to describe things a little bit differently. So for example, we'll look at this one here again. The ratio of the number preferring new extra crunchy to the number preferring regular crunchy is 5 to 4. So 5 prefer the new, 4 prefer the old. And here we're saying the number preferring new extra crunchy, that's that same first part here, is 5/4 of those preferring regular crunchy. We are just putting the fraction or the ratio in between the two numbers to compare them. Let's do part C. If the company is planning to produce 90,000 containers of crunchy peanut butter, how many of these containers should be the new extra crunchy variety, and how many of these containers should be the regular crunchy peanut butter? What would be helpful in solving this problem? Does one of our comparison statements above help us? So they want to make 90,000 jars of peanut butter. Okay, and we need to figure out how many should be extra crunchy? So how many should be extra crunchy and how many should be regular crunchy? You guys, I'm sorry that they did regular crunchy and extra crunchy. That's kind of confusing, but we'll live. Okay, so extra crunchy, regular crunchy. So we know that 5 out of 9 people prefer extra crunchy. And we know that 4 out of 9 people prefer regular. So what we can say is that 5/9 of this number should be extra crunchy. Okay. 5/9 should be extra, and 4/9 should be basic or regular. Okay. /regular. Okay, so the way we can figure this out is by multiplying this number and this number together. But it's not asking us to do that, so I'll let you guys do that on your own if you want. I'm actually going to do problem 1 on the problem set with you guys, whatever. So Maritza is baking cookies to bring to school and share with her friends for her birthday. The recipe requires 3 eggs for every 2 cups of sugar. Okay, 3 eggs to 2 cups of sugar. To have enough cookies for all of her friends, Maritza decides she would need 12 eggs. Okay, so she needs 12 eggs. If her mom bought 6 cups of sugar, does Maritza have enough sugar to make the cookies? Why or why not? So what we want to do is make an equivalent ratio. Well, how do I go from 3 to 12? I multiply. Ooh, I'm not supposed to use that anymore, right? I multiply by 4, but now that looks like 0.4. So I'm going to just cheat and use this. Times 4. Okay. I'm going to multiply. It didn't write. No. Okay. Multiply. Okay. 3 times 4 is 12. Well, if I multiply this one by 4, I got to do the same thing. I got to multiply this by 4. Okay. 4 times 2 is 8. So she needs 8 cups of sugar. So she does not have enough sugar. Nope. Not enough. I'm so sorry it looks like this, guys. I'm trying a new program and I don't like it. Not enough sugar. Okay, I'm going to let you guys figure out 2 on your own. If you need help, ask me in class, ask a classmate. And once you're done with the problem set, don't forget to do your exit ticket. Bye.